Hey guys, welcome back to the channel. Today I am in Metuchen, New Jersey, and I'm here to do a panel upgrade. There's an existing 100 amp service and they were having a problem with their air conditioner circuit. It was buzzing on the bus bar, so the bus bar is obviously failing, so we're replacing the panel. We're going to go from I think a 16 circuit panel to a 30 circuit panel with the capacity for 60 circuits. I don't think they're ever going to be using more than 30 circuits in here, but I could be wrong. Who knows what the future holds. So welcome back to the channel and let's get started.
This customer is a longtime subscriber to my channel. His name is Tyler. Hello, Tyler. So Tyler called me because the air conditioning condensing unit circuit breaker was buzzing, and when he had an HVAC company come out and take a look, he noticed that this circuit breaker was burned up onto the bus bar. So Tyler wanted me to change this panel and upgrade to a 100 amp 30/60 circuit space panel. So as with most panel upgrades or service upgrades, the first thing you want to do obviously is shed the load, which means turning off all of the electrical circuits in this panel here before you pull the meter on the outside. Now sometimes in this area, PSE&G, most of the time they have their circuit breakers locked. They have their meters locked. This particular meter was unlocked, and so I was able to access the meter without having to call PSE&G out first. Of course, I could have done that. The permit opens up that door, and PSE&G will not come out and unlock a meter unless you have a permit number. But that wasn't the case here. We did apply for a permit, and we'll have an inspection in a week or two from the time that I upload this video. So once the load is shed and the meter's been placed in a spot where it won't face damage, I come back downstairs into the basement after setting up, and I set up two sawhorses now with a sheet of plywood, and that's my table, and that's what I seem to like right now. It's a little bit more work to bring all that stuff in, but the room that I have on this table now makes it all worth it. I can set up my materials. I have a little workspace, a little workbench to work from, and I also have a spot to put my fans, which, as you know, in New Jersey here the past few weeks, it's been very, very hot. So I usually have a couple fans going, and this job was no different. So once we remove all the branch circuits, we remove the old panel and disconnect the lock nut and the bonding bushing, and now I'm able to open up my new panel and install the new panel. Now, one of the challenges here is I wasn't sure how this panel was going to sit on this old mounting board. The mounting board that's there now is on so good that I didn't feel the need to actually have to change it. Tyler, the customer, was okay with this, and so the biggest challenge there is this panel going to overlap the mounting board, and it didn't. As you can see, it goes right to the bottom there, and we used a concentric knockout that was existing. That was a concentric knockout on the electrical panel itself, so I didn't have to make a custom knockout for this, which always makes for an easier installation. So I'm doing some much necessary bonding right here, okay? So that steel pipe, when you do a panel upgrade, it stays the same. If you're doing a service upgrade, that's a complete upgrade, then you would change that. Obviously, if it's steel, it needs to be bonded to the system neutral. And of course, if it's PVC, you don't have to do this, okay? It seems obvious, but PVC is not going to conduct electricity, so therefore it's not going to ever be energized, and so the code says if it's got the possibility to become energized, then it must be bonded. If not, then there's no sense in doing that. So even when you're panel upgrading, you still have to put in a whole house surge protection device. It's required by section 230 TAC 85, I believe, is the code. And so anytime you upgrade a panel only, we have to put the whole house surge protection, and in New Jersey here, we have to update the grounding electrode system, which you'll see later in this video. If you haven't already, now would be a good time to like this video and subscribe. And if you're enjoying this video, hit the notification bell so you get updated every time I upload a new video. These are the directions that come with the whole house surge protection device by Cutler-Hammer that you see me installing in this video. And I wanted to emphasize 2 of the 4 bullet points we see here. The third one says, when connecting the wires from the Cutler-Hammer surge protection device to the electrical system, cut the wires as necessary to keep them as short as possible. 12 inches or less is recommended. To maximize the Cutler-Hammer surge protection device performance, twist and bind the wires together to reduce the impedance of the wire, 1 twist per inch. I just wanted to highlight these important instructions by the manufacturer because, of course, the National Electrical Code also has a section that demands or requires that we install to the manufacturer specifications. If you found this helpful, hit that like button, and if you have any questions, be sure to leave them in the comments. Grounding and bonding is a big part of what electricians do. It is often misunderstood, and so I'm going to take a moment here to go over a few things that are important in learning grounding and bonding from the National Electric Code. This is a new sort of segment for my channel, and I hope you enjoy it. General requirements for grounding and bonding. Electrical systems that are grounded shall be connected to earth in a manner that will limit the voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines, and that will stabilize the voltage to earth during normal operation. Normally non-current carrying conductive materials enclosing electrical conductors or equipment or forming part of such equipment shall be connected to earth so as to limit the voltage to ground on these materials. The grounding electrode system. All grounding electrodes as described in 250 TAC 52A1 through A7 that are present at each building or structure served shall be bonded together to form the grounding electrode system. Where none of these grounding electrodes exist, one or more of the grounding electrodes specified in 250 TAC 52A4 through A8 shall be installed and used. A meter underground water pipe in direct contact with the earth for 3 feet or 3 meters or 10 feet or more, including any metal well casing bonded to the pipe and electrically continuous or made electrically continuous by bonding around insulating joints or insulating pipe to the points of connection of the grounding electrode conductor and the bonding conductors or jumpers if installed. Rod and pipe electrodes shall not be installed. Rod and pipe electrodes shall not be less than 8 feet in length and shall consist of the following materials. B. Rod type grounding electrodes of stainless steel or copper or zinc coated steel shall be at least 5/8 of an inch in diameter unless listed. Grounding electrode system installation. All grounding electrodes as described in 250 TAC 52A1 through A7 that are present at each building or structure served shall be bonded together to form the grounding electrode system. Where none of these grounding electrodes exist, one or more of the grounding electrodes specified in 250 TAC 52A4 through A8 shall be installed and used. Metal underground water pipe. If used as a grounding electrode, metal underground water pipe shall meet the requirements of 250 TAC 53D1 and D2. Continuity. The continuity of a grounding path or the bonding connection to interior piping shall not rely on water meters or filtering devices and similar equipment. Supplemental electrode required. A metal underground water pipe shall be supplemented by an additional electrode of a type specified in 250 TAC 52A2 through A8. If the supplemental electrode is of the rod, pipe, or plate type, it shall comply with 250 TAC 53A.
Alright, so as you can see here, that's what happens when it's pitting. We'll call that pitting up against the bus bar. It's just not making the right connection. So either the circuit breaker failed or the bus bar, or a combination of the two, and I believe it was a combination of the two.
I think what we'll do is we'll attach this first.
And then I drove the other one here using my SDS Max. You've seen me drive.
Doing this work is probably my least favorite thing to do. Just getting down in the dirt here and burying the wire and making the connections. It's hot, and when it's hot, the dirt likes to stick to my body, and so it's just an uncomfortable feeling. But if you do the things that other people don't want to do, you'll always be successful. So keep doing them.
It is pretty damn hot here today and humid. It's raining on and off all morning. In fact, when I left Point Pleasant this morning, it was raining like crazy. It's very hot.
So I guess you could say the nice thing about this particular panel upgrade is I'm using all non-metallic sheath cable, which is a bit easier to work with than an old armored cable. The other nice thing is I would say the majority of these conductors were long enough to work with without doing splices. And of course, I get this comment occasionally, but splices and wire nuts and that sort of thing inside an electrical panel is totally permissible. If you look at Article 312 Tac 8, you'll see all the information you need to know there about making splices inside of a panel. So if you think for a second that that's not allowed, you're wrong. So being that this is a main breaker panel, all my grounds and neutrals are bonded, and right above where I'm working, right there behind the lug, I don't know if you can see it, is that green screw, and that's the main bonding jumper. It's a screw, and what that does is that bonds the neutrals to the enclosure, forming a bond between the enclosure and the neutral so that everything's properly grounded and connected to earth. Now don't get me wrong, there's actually two things that you do with grounding. Grounding, in case you get hit by lightning, it'll induce a voltage on your circuit conductors. We want to make sure that it has a nice clean path, a low impedance path to earth. And then we have equipment grounding, which is really what we call bonding, and that's going to actually clear a fault in the case of a ground fault situation. So big difference between grounding and bonding.
Take a small piece like this and you rub off everything on that pipe so you can expose it to the bare copper. Plumbers know what this is, obviously. I feel kind of bad. The last couple ones I've done, they weren't as corroded, not corroded, but they weren't as colored as this one. So I got away with not doing it, but it's important to do it. So that my dual rated aluminum copper water ground clamp here gets a nice good bite onto the copper. So you'll notice, like the last house in South Plainfield, we did the service upgrade there. And I'm only thinking about that because I was there yesterday to meet the inspector. It passed inspection, no problem. But like the house in South Plainfield, this house here has a water meter outdoors. So you still need to bond it because this section right here goes through the earth out to the city water. All right, so because this copper is embedded into the earth, and the earth, as Mike Holt always says, the earth doesn't have terminals. We bond this piece of pipe right here with our grounding electrode conductor to our grounding electrode via this clamp, and now this copper water pipe becomes our electrode because it's connected inside the earth. And let's just see if this water heater is already jumped out. It is. I hope you could see that right there. So the cold water comes in one of these sides. I'm not sure which side, but it comes in on one of these sides and it goes out hot. So what we need to do is put this jumper in so that all of the copper water piping in the system is bonded to the grounding conductor here at the main disconnect. Oh, I got to get the GFCI breaker here, and I need to do the condensing unit wiring. I got about 10 minutes to get that done before my 3 o'clock deadline that I promised my customers that the power will be back on, being that this was just only a panel change only. So I can get done a little bit early. Had this been a full upgrade, I would have come here the day before and done the grounding system so that I could be ahead of the game, so the power will be off less than if I wasn't there the day before doing advanced work. So
this is the kind of job that I really like doing, because this actually takes a dangerous condition away from the homeowner and the people that live in this house who were worried that their electrical panel might catch fire one night. That's a real concern for people. So when you take that away and you make a safety improvement to a customer, for me, that's a good feeling. And I still take that with me every day to work. And if you're an electrician watching this and you're aspiring to be a licensed electrician, I hope you carry that kind of feeling with you as well, because it'll serve you well in the trade.
Alright, now some of you might be wondering, gee, you put the meter in, is the panel live? The answer is, sort of. So power is coming in through these service entrance conductors onto the main breaker, okay? So once I turn this main breaker on, then the bus bar becomes energized, then we're back in business. But I just need to finish attaching this air conditioner, which is probably going to be the first thing that goes on. Okay, here we go.
If you've enjoyed this video and you've learned something from watching this video, do me a huge favor and smash that like button. Thank you. This is my secret weapon, the Brother the Brother E550. It's a great label maker. Occasionally I have some problems with the cartridges not coming out properly. You got to reset it. But for the most part, this label maker has really served me well. Highly endorse it. You can find it on Amazon.com, which is where I found mine. So if you're looking for a label maker, and I put labels on everything now because the code really requires it almost everywhere. So this is the Brother E550.
But I can finally take off my tool belt now, and I'm good. Hey, by the way, this is the new Tempo, Diamondback Tempo tool back. This is the big Nico electrician's pouch with the ox for my wire nuts, etc. Then a little Saks bag there. The Tempo belt, I really like this. Don't get me wrong, I love the Atlas 46, but I think the Diamondback is winning out. It just feels more comfortable. Highly endorse it.